So today we will be going over our third lab experiment for the semester. And this lab experiment is on different ways of creating a potential difference, or what's called an electromotive force, that pushes electrons through a circuit. So you've already seen the power supply, which basically uses electricity to separate electrons from their respective protons. You have a surplus of electrons on what's called the negative terminal and a deficit of electrons on what's called the positive terminal. And so that energy is supplied by electricity coming through the coming from the plug or from the socket. There are other ways that you can create this separation of positive and negative charges. And you create a positive end and a negative end. And again, when you connect a circuit to the positive and negative ends, the electrons flow out of negative through the circuit and towards the positive. And so one way we're going to be looking at is a thermocouple, which uses a temperature difference to create a positive and a negative terminal. And we're also going to look at a photocell or a solar cell, where light provides the energy that kicks electrons out of their atoms and, again, creates a positive and a negative terminal. So we're going to be looking at a couple of different ways of doing things. And the other thing is the battery. Batteries use chemical energy. So a series of chemical reactions inside the battery separate or create a buildup of electrons on one side, which is called the negative end. And again, the deficit of electrons on the other end creates a positive terminal. So you connect that in a circuit and a current will flow. So we're going to start with the battery. And so we'll have two different batteries that are going to be otherwise basically identical. We're going to connect them a couple of different ways and measure the voltages, voltages across them. So we're going to have a digital multimeter that measures, we're going to set it to measure voltage, but it can measure current and resistance and other things as well. And so we have two different batteries. We're going to connect them in series with each other. So we're going to connect them to each other, first the positive terminal of one end to the negative terminal of the other end, and measure the voltage across the back leg of the first one to the front leg of the second. And then we're going to have the positive terminals face each other, and you're going to measure the voltage on either end. And then you're going to have the negative terminals of the batteries face each other and measure the voltage from end to end. And you should be able to guess, ahead of time what you expect to see for the total voltages. So you're going to measure the individual voltages, and like I said, then you're going to do the two in different combinations. And so you can guess what the voltages should be and see if that's borne out by the measurements. Then you're going to connect, and again, when I say I'm doing the procedural work, but you'll be able to observe it, and you're going to record the observations as you see them on the video. So you're going to connect the two batteries to a 100 ohm resistor, and you're going to measure the voltage across that resistor. And then you're going to repeat for the 1000 ohm resistor. And you might see that they are slightly different results, that you might expect that the full voltage that you get across the two batteries when you connect it to a resistor, that voltage is going to go across the resistor, but it doesn't quite work that way. And so you'll notice the difference between 100 ohms and 1000 ohms, and try to guess what the reason, why those answers would be slightly different from each other, because they will be slightly different from each other. Then we move on to the thermocouple, and the thermocouple again creates a voltage using temperature differences, and you'll see from in the experiment that the voltages you get aren't all that large. And so you start at room temperature. Room temperature being, I think it was 73 degrees Fahrenheit. So you're going to need to convert that to Celsius. And then the body temperature, I didn't do a direct measurement of the body temperature, but you can use 98.6 degrees Fahrenheit, converting that to Celsius. So what you're going to do is you're going to squeeze down on the open end, or what I did was squeeze down on the open end with my finger until that got the temperature of my body temperature. So it's going to be a little bit warmer than it is in the room. And you should notice a change in the potential difference from that. It'll be more noticeable when you expose the open end of the thermocouple to ice and to boiling water. So the ice is going to be at 0 degrees Celsius, and the boiling water is going to be at 100 degrees Celsius. And so you should, the difference in the voltages you get is going to be much more obvious. So then what you're going to do is make a plot of voltage or EMF versus temperature, and set it to a linear fit or a straight line fit with a y-intercept. And from that fit, infer what the EMF would be if you expose the open end of the thermocouple to a temperature of 200 degrees Celsius. So that's going to be included in the lab report. And then the last part is the photocell, basically a solar cell. And so the light kicks out electrons and makes a current as a result. And so you get a potential difference out of that. So you're going to have a photocell. You're going to measure the voltage across the photocell with ambient room light. Then you're going to measure the voltage again when it's covered by an opaque object that's blocking as much light as possible. So you'll be able to see those readings. Then what you're going to do is put the photocell underneath a bright lamp. And in the lab, we'd use a flashlight app on the phone. I had a regular tabletop lamp that worked better. Given what I have, it worked better. So that's what we're going to use. So you put the photocell under that, you get that reading. Then you're going to put one sheet of white paper on top of the photocell, get a new reading. Then do that for 2 sheets, then 3 sheets, and then 4 sheets. And you're going to make a plot. It doesn't necessarily have to be a linear fit. In fact, it shouldn't be a linear fit. And so you're going to make that plot of EMF versus the number of sheets of paper. Play around with it, try different types of fits, see what gives you the best, best fits your data. And once you have an equation that you think fits your data well, ask yourself, or from that equation, what do you think the EMF from 6 sheets of paper would be? And obviously, even if you'll be able to see that if you put 6, it should be less than what you get when you put 4. And but it should still be greater than 0. So if your fit doesn't give you a value for the EMF of 6 sheets that's between what you had for 4 and 0, you might want to try a different equation. So play around with that, see if you get a fit that works with the data that you have. Okay, so that's the basic procedure. And so you're going to go over the other video, the bigger video. That's going to go through the procedure for you. And so you're going to take the data directly from that. You're going to fill up some tables. So look at the lab write-up. And then fill out the lab report. And so again, on Monday, I'd like to see one of the lab partners post a video demonstration of how they analyze the data, and then another lab partner write the formal lab report. And so the video is going to go under discussions. The lab report is going to go under assignments. And if you have any questions, don't hesitate to ask me for help. Okay, so with that, I will see you soon.